Dumelan, again, grade 11. We look at another example that is question 4 of Gauteng June exam 2022. And this one has to do with stoichiometry. They say consider the reaction between sulfur dioxide and oxygen. So your reactants are sulfur dioxide and oxygen to produce, and your product is what? Sulfur trioxide. Now they ask you to define 1 mole of a substance. What is 1 mole? In grade 10 and grade 11, you've been taught that a mole is basically the amount of substance with the same number of particles as there is in 12 grams of carbon 12. That is the definition of a mole. 2, they say, so that was 1. 2, they say write down the balanced chemical equation for the reaction. So you know that sulfur dioxide, SO2, reacts with oxygen, and remember oxygen is diatomic. You don't just write O, you write O2 to give you SO3. Right. If you look at that, okay, we'll take it back to grade 10, how you get to balance your chemical equation. Let us look at the reactants and the product. You have sulfur and you have oxygen. How many sulfur atoms do you have? On the reactant side, you only have this one, so you have 1. And oxygens, you have 2, 4. That is 4. And we look at the products. How many sulfurs? You have 1. How many oxygens? You have 3. So sulfur is balanced, so you might not want to touch this for now. Oxygen is not balanced. You want to make sure that it is balanced. In this side, you have this 2 plus the 2, and in this side, you have the 3. What you can do, let us look at this. If you put 2 on the side, you now have two sulfur atoms, and you have 2 times 3 oxygens, which is I'm sorry about that, which is 6. And remember, you want to try and balance the two, right? The reactant and the product, to make sure that the amount of particles you have in the reactant side is the same as with the product. You now have 2 sulfurs, and this side you have 1, you have 6, this side you have 2 and 2. So what you can then do is, if you put 2 there, that is 2 times 1, which is 2, and 2 times 2, which is 4, plus this 2, which is now 6. So you have 2 sulfurs on both sides and 6 oxygens on both sides. So it is balanced. So the balanced equation would be 2SO2 plus O2, giving you 2SO3. Let me just write that out. That was question number 2. Then they proceed to say, if 14 grams of sulfur trioxide is produced at standard temperature and pressure. Remember, at standard temperature and pressure, you know that you have Vm, or your molar volume, which is 22.4 cubic decimeters. That is the molar volume. So they say if 14 grams of sulfur trioxide is produced at standard temperature and pressure, calculate the volume of sulfur dioxide required in the reaction. Let us look at that. You are given the mass of SO3, which is 14 grams. You are then able to calculate the number of moles of SO3. Number of moles of SO3 equals to its mass over molar mass, which is 14 over sulfur is 32. We know by now because we've been doing a lot of questions. 32 plus 3 oxygens, and oxygen is molar mass is 16. Let us calculate quickly. You have 14 divided by 80, which gives you 0.18. 0.18, or you can write it in full, which is 0.175. So you have 0.18 moles of what? Sulfur trioxide. Now, the question says that if 14 grams of sulfur trioxide is produced at standard temperature and pressure, you have to calculate the volume of sulfur dioxide. You got the number of moles of sulfur trioxide, but you want the volume of sulfur dioxide. And what you're going to do is you're going to compare the mole ratios, sulfur trioxide and sulfur dioxide. So you have SO2 is to SO3. The ratios are 2:2. And so that they're equal. If you know the number of moles of sulfur dioxide is going to be, of sulfur trioxide, whatever is going to be the same way as sulfur dioxide. So it is 0.18 mole, and which is also, which means that SO2, the number of moles of SO2 is going to be 0.18 mole. So you now know the number of moles of SO2. You know that it is 0.18 mole. Right. And then you want the volume of sulfur dioxide, because they say that the sulfur trioxide is produced at standard temperature and pressure. Then you're going to use the formula N equals to V over Vm, right? So that is the number of moles of SO2, right? And the volume of SO2 and the molar volume, which is a constant. If you cross multiply, then you get volume of SO2 equals to the number of moles of SO2 multiplied by Vm, which is 0.18 multiplied by 22.4 cubic decimeters. Let us get that very quickly. 0.18 times 22.4 gives you 4,03. Remember, volume has to be in cubic decimeters. And you got the volume of sulfur dioxide. This was question number 3. That was 2, and that is 1, and that is 3. Okay. The next thing, actually 3 starts here. The next thing that they're asking you to do is to calculate the mass of oxygen that has been used up in the reaction. You want the mass of O2. And again, using the mole ratios, you are able to get the number of moles of oxygen and then get the mass of oxygen. You want the mass, but the number of moles of O2 you can get using the mole ratios. Let us compare sulfur dioxide and oxygen. So you have SO2 is to O2, which is 2 is to 1. Mass of number of moles of SO2 is 0.18 mole, and this will be 1 over 2 multiplied by 0.18, because we said in order to get the number of moles of oxygen, if you have the number of moles of sulfur dioxide, you're going to say the coefficient of oxygen divided by the coefficient of sulfur dioxide multiplied by the number of moles of sulfur dioxide, and that is 0.18 divided by 2 is 0.09, 0.09 mole. And the next thing you're going to do, now you now have the number of moles of oxygen, right? You can then calculate the mass of oxygen. From the formula, N equals to mass over molar mass. Mass will be number of moles multiplied by the molar mass. Number of moles is 0.09 multiplied by oxygen, you have 2, right? 2 times 16, which is 32, multiplied by 32, and that gives you 2.88, sorry. So the mass will be 2,88 grams, and that is the mass of oxygen that has been used. Right, this concludes all the 4 questions that we were given. Remember, with stoichiometry, you first want to make sure that your equation is balanced. And if you make sure that your equation is balanced, then you're going to use the mole ratios to find the number of moles of the other ones if you have the number of moles of one, either the reactant or the product. So I hope this was helpful for you grade 10s and grade 11s. Bye-bye.